and this is Miss Glover going over our review guide for our work, power, energy, and momentum and collisions test. Number one, Molly's almost late for class again. If the 60-kilogram girl runs up the 5.5 meter flight of stairs, how much work does she do? Work equals force times distance. And in order to get the force equals mass times the acceleration of gravity, 9.8. So to find the work, we would take her mass, 60 kilograms, multiplied by the acceleration of gravity, 9.8, and multiplied by the distance of 5.5 meters to get a value of 3,234 joules. What's her power? Power is the work per time. So we take the value of the work, 3,234 joules, divided by the time of 3 seconds to get her power of 1,078 watts. Power is units of watts. Then to calculate the power needed for a 150-pound person to climb the staircase in 6 seconds, assuming the stair has 10 steps and each step is 8 inches tall. So this one's a little bit of conversion, where again power is work per time, and this would be the force times the distance per time. So the conversions I'd have to do is that 150 pounds, and that there's 2.2 pounds per 1 kilogram, and then I could get the mass in kilograms. Calculator. So I get 68.2 kilograms is the mass, and to get force, again, you have to take mass times 9.8. And the distance, 10 steps, each step is 8 inches tall. So we're talking about 80 inches. And there's 12 inches to 1 foot. And then 3.281 feet per 1 meter. So 80 divided by 12 divided by 3.281. is 2.03 meters. So this would be times 2.03 meters divided by a time of 6 seconds. And that's where you could get your 230.7 watts. The last one in this section is a child pulls a sled with a force of 45 newtons, but they are pulling at an angle of 30 degrees above the horizontal. How much work is done if it's moved 15 meters? Well, remember for this, the force that's actually doing work is just the component of the force that is pulling it forward, the actual direction it's moving. So we'd take the force, 45 newtons, times the distance of 15 meters, times cosine 30 degrees. And if you multiply those, that's how you get 584.6 joules. And for the energy section, a PR baseball player wants to show off his skills by catching a 0.15 kilogram baseball dropped from the top of a 100-meter tall building. And what is the speed of the ball when it's fallen to the height of 35 meters? So the idea is it's dropped up here at 100 meters. So up there it had potential energy. And then down here at 35 meters, it's got potential and kinetic. And what we know about energy is these two would be equal to each other. So the PE at the top will equal the PE plus KE at 35. So mg times 100 will equal mg times 35 plus 1/2 mv squared. A good tip to learn, just in case you weren't given the maths on this, is that the m's can cancel out. So gravity times 100. And then you subtract gravity times 35. And that would equal 1/2 v squared. So you can get this and multiply by 2. And then take the square root. And that's how you get the velocity is 35.7 meters per second. The PR baseball player dives at ground level, trying to be fancy as he catches the ball. What's the speed of the ball just before it strikes the glove? So for that one, we're continuing on to find it at the bottom where there's just KE. So for this one, you can use the PE at the top equals the KE at the bottom. So mg times 100 meters will equal 1/2 mv squared. M's can cancel, and take 980, multiply by 2 to get rid of the 1/2, and that would equal v squared. So then you could solve for v to be 44.3 meters per second. Oops, John's trying to put his groceries in a cart at point A, but the 15-kilogram grocery cart gets away from him and begins to go down the 10-meter hill from rest. So up here we just have potential energy. At point B you would have potential and kinetic. To find the speed at the top of that hill, then we put the potential energy at A will equal the PE plus KE at B. So mg times 10 meters will equal mg times 6 meters plus 1/2 mv squared. And you could just cancel the m's out of all of that if you want. 98 minus 58.8 equals 1/2 v squared, and from there multiply through by 2, take the square root to get the velocity is 8.85 meters per second. To find the total energy of the cart at point A or point B, at A it's just potential, so that would be the mass times gravity times height. Remember that is the same at B then. Same total amount of energy. For your momentum, an impulse, which is more momentum, a 500-kilogram elephant running at 5 meters per second or a 5-kilogram rabbit running at 500. Momentum is mass times velocity, so it really doesn't matter if you take 500 times 5 or 5 times 500. They are the same amount of momentum. Number 7, Jim hits a stationary 0.45 kilogram puck with a force that lasts for 0.045 seconds, makes the puck shoot across the ice with a speed of 21. What force did he hit the puck with? And we can use the impulse equation, where force times time equals mass times change in velocity. So force times 0.045 seconds equals the mass 0.45 kilograms times VF 21 meters per second minus 0, the initial velocity. So from there you can solve for the force to get 210 newtons. What is the impulse? Well, impulse could be either side of that equation. It could either be the force times time, or it could be the mass times change in velocity. So choose whichever you would like. If I did 210 newtons times 0.045 seconds, I could get 9.45. And the units of impulse are the same as momentum, kilogram times meter per second. Moving to the back, collisions here. Pretty funny to watch Chicken hit in the face by a gun. So let's say the chick is holding a gun with a bullet at rest, and she fires the .005 kilogram bullet with a speed of 250. With what speed does the gun hit her in the face? So this is a conservation of momentum problem where they all lead off of the initial momentums will equal the final momentums. Initially, everything's at rest, so that would equal 0. This is like an explosion problem. So if she fires a .005 kilogram bullet with a speed of 250, what speed does her 9 kilogram gun hit her in the face? So to solve this, you'd multiply that, move it to the other side. So you get negative 1.25, and then divide by 9 to get negative 0.139 meters per second. The negative just means it's in the opposite direction, because this is like recoiling. 2 billiard balls. The 14 ball with a mass of 2 kilograms and the white ball with a mass of 2.5 kilograms collide elastically in a head-on collision. The 14 ball is traveling at 0.2 meters per second to the right, and the white ball is traveling at 0.3 to the left. After the collision, the white ball continues to move it to the left at 0.05. What's the final velocity of the 14? So again, conservation of momentum. The first mass is 2 kilograms. At 0.2, I'm going to make to the right positive, to the left negative, plus the white ball, which is 2.5 kilograms, traveling to the left, so negative 0.3 meters per second, equal to, after the collision, the white ball continues moving to the left, so that's 2.5 kilograms, and it's still going left, so that'll be negative at 0.05. Plus, sorry, I gotta continue below, 2 kilograms at some velocity v. Make sure I can get all that. So to solve for that velocity v, multiply these, you're subtracting that because this is a negative number. Multiply those, this is a negative number, so you're actually adding it to the other side, and then divide by 2, and you should get 0.11 meters per second. You get a negative number, so that means that this is to the left, based on the way I set up my sign convention. Number 10, a 10,000 kilogram freight train car moving at 1.5 approaches a car at rest with a mass of 15,000. What's the mutual speed after they collide and stick together? So this is a pi collision. Same idea, initial momentum equals the final momentum. Initially you had the 10,000 kilogram car moving at 1.5. The other one was at rest. After the collision you have 10,000 plus 15,000 at some velocity v. And from there you can get the velocity together is 0.6 meters per second. Should obviously be less than the initial velocity because now you've gained mass with the same amount of momentum. How much energy was lost? To figure out the energy lost, you want to think about the amount of energy started with, 100 times 10,000 times 1.5 squared, minus the energy you ended up with, 1,000 times 25,000 times 0.6 squared. And you would end up with 6,750 joules, and that would be joules lost, or changed into heat, work, etc. Okay, just finishing out the back page here, number 11. For the egg drop competition, Brian and David put their 60-gram egg to the test in their 35-gram container. They drop it out the window at a height of 9.15 meters above the ground and hope for the best. How much PE does the egg and the container add? So the mass is 95 grams, or to convert that into kilograms is 0.095 kilograms. You just move it back 1, 2, 3 spots. And the height is 9.15 meters. So using potential energy equals mgh, I get 0.095 kilograms times gravity times 9.15 meters. and that's where you get 8.5 joules. What is the velocity of the egg just before it hits the ground? Same idea at the window here, you have potential energy just before it hits the ground. That's all changed into kinetic energy. So the PE at the top equals the KE at the bottom. So 8.5 joules would equal 1/2 times the mass times velocity squared. And that's where you can get the velocity as 13.4 meters per second. What's the momentum of the egg and the container just before it hits the ground? Momentum is mass times velocity. So 0.095 kilograms times 13.4 meters per second. So we get 1.27 kilogram meters per second. What impulse is supplied to the egg as it brings it to rest? So impulse is the change in momentum. So the final momentum is 0 because it's at rest, minus the initial momentum was 1.27. So it's the same thing, just negative 1.27 kilogram meters per second because it's bringing it to rest. Part E, if it took 8 seconds to stop the egg and container, what's the force on the ground in the container? Use force times time equals change in momentum. So force times 0.08 seconds equals, also equal to the impulse, negative 1.27 kilogram meter per second. So if you divide through, solve for the force, you get negative 15.9 newtons. What's the force of the egg in the container on the ground? Well, if A exerts a force on B, B exerts an equal and opposite force on A, so it would be 15.9 newtons, the same amount of force, just opposite and equal. Okay, thank you for joining us. Good luck on your test. Bye.